Hello, everyone. Yes, I'm Matthew Hardy. I've been working at Adobe now for 20 years. I've been involved with PDF for about 26 years. Many of you will know me from accessibility talks, my work at ISO and the PDF Association, running things like the Reuse Technical Working Group and PDF UA Technical Working Group. But today I'm actually going to talk more about the sorts of things I've been interested in at Adobe for the last decade. Why don't we start off just reminding ourselves of some of the challenges that PDF faces in the industry. So when we think about PDF and its invention 30 years ago, it's basically been, its primary focus was on interchange of visual material. And in the early days of PDF, capturing exactly what you saw on the screen when you transmitted that to someone else was the main primary focus of what we wanted to do. And rich print capabilities followed on that. So basically, the goal was fixed layout, independence of pages, and PDF was incredibly successful in that space. That's not to say that we didn't think about things beyond just appearance and visual content. As early as PDF 1.2, PDF started to adopt things like marked operators, where I could put metadata into the content streams to identify properties of the content. By PDF 1.3, we'd added the ability to do logical structure at a high level so that companies could interchange logical information about their documents. And finally, with PDF 1.4, we introduced Tagged PDF, which is now the basis for all these standards like PDF UA, well-tagged, and such for content reuse, accessibility, interchange. So these were there. The foundations have been present for a long time. And they were built in a way that built on top of each other. None replaced the other. You can still use marked content for its original purposes, but it's part of logical structure, which is part of Tagged PDF. So these capabilities have been around a long time. Unfortunately, the primary path to getting to PDF has been printing. People, if you can produce a good visual representation and you can then distill that down to a PDF, you can take away the appearance you want and have it guaranteed across surfaces. But this path doesn't help you with that richness of content. It doesn't help you put the data into that content. And so one of the key challenges we've faced is that the fastest and easiest path has been to throw away all that rich metadata in the original format. I look at LaTeX as a great example of something that's been evolving now recently, but historically I have all this rich semantics, and then I create this PDF that loses all of that, and all I'm left with is basically a picture. Granted, a vector picture, not just an image, but something very, very, very simple. And unfortunately, the paths to do richer output were far fewer. We do see some. I mean, I know we had that great keynote at the start of the day, and it's very true that very few applications do a great job just out of the box. But you can see things like Microsoft Word producing high-quality tagged PDF if the author does all the right things up front. So there are paths there, but they're definitely the minority. Actually, that number we saw, that 4-point-whatever%, 5%, actually matches very much what Adobe has seen in the industry, that basically about a fifth, 20% of PDFs are actually tagged. Only about a quarter of that 20% is well tagged, is good quality. I won't overload the term. And so it leaves us in a challenging place. So, I may have jumped ahead there. PDF changed the world. We heard the number billions of PDFs earlier, but it's actually trillions. There's so many PDFs in existence, and the vast majority are being produced through this legacy path, through this very simplistic path. That leaves us with a problem because we have all this powerful data locked up inside of PDFs that have been distributed for many, many years. And so in the best case, we have tagged but poorly tagged PDF for the vast majority, and actually for 80%, no tagging whatsoever. So that leaves us with a key challenge. And so about a decade ago, Adobe and many other partners here at the PDF Association started looking at the things we could do to try to address this. And one of the key aspects we focused on was responsive PDF that could actually respond to the device. So when you think about the world of the 90s when PDF was first being invented, it was really a challenge to interchange that information. But computers look like computers. Print was putting it onto a A4 or a US letter piece of paper. It wasn't necessarily thinking about dynamic screen sizes, the fact that I'm walking around with a portable screen at all times, that I want that same content to adapt from a small to a large screen, even to a watch. And so this was one of the key challenges we undertook first. As a group, it wasn't just any one company. We created an RPDF project in search of the PDF Association. Tagged PDF actually is the intended solution for this. If you get a very high-quality tagged PDF out of a good piece of software, so the newer versions of LaTeX, if you publish a PDF UA2 or a well-tagged PDF out of these, you have a fantastic starting point for great experiences with responsive and dynamic layout and other capabilities. But unfortunately, as we just talked about, that's not the case. And so one of the key things we started to do was turn to artificial intelligence to try to solve this problem. And so at least within my company, but I'm not talking about any specific product here, we actually combined several things. For many years, there's been a system that allowed what was called a black box static analysis engine. The University of Nottingham, where I studied for my PhD, actually created this original stasis engine that could look at a PDF, it could analyze various properties and start to do things like tagging it and restructuring it. But if we combine that with AI, could we do much more? And so we started looking at things like object detection models. Could you look for things on the page and do a higher quality of feeding that into those heuristics to produce high-quality tagged PDF, something that was actually going to work? Now, this actually created a fantastic talk internally at Adobe called PDFs Are Not Cats. And where did this strangely named conversation come from? Well, it was the fact that a lot of object detection models are focused on real world, where if I take a photo of a room like this, there's a natural order to it. There's going to be maybe people in the photo and tables. And so if I train classic AI, YOLO X, sort of the you only look once model on this sort of information, it's actually relatively easy to pick out specific types of objects. But when you get to things like PDF, the content in PDF is art. It's not fixed in layout. You can have strange spiral documents. You can have very complex tables. You can have things that defy exact categorization. And so through a very intensive data process, which I'll talk about in a minute, we were able to train models that could understand the objects on the page, pass those into the engines that can then decompose them into words and characters, reading order, and actually do a reasonably good job of presenting that content in a responsive manner. So our first target was the derivation, and that's been standardized by the PDF Association. Roman is the chair of the derivation committee. But the ability to take that tagged output that's now generated by AI and actually produce responsive content and actually adapt it to the screen size to understand the properties of that content is really important. Things like magnification and reflow become possible, where you're not just zooming in and panning around small bits of content, but you can adapt the content to the screen. You can even retain the look and feel of that content. So basically, we can take the styles from the original PDF, the fonts from the original PDF, and retain those. More importantly, we have a link back. The PDF is still the PDF. There's no loss of information. You can always get back to the ground truth, that document of record. So this was one of the key projects and first enablers of AI that we saw. It's not the only one. There's plenty of other AI projects in the PDF space. But I think this was trying to solve a key challenge that faced PDF in the early days. It's also very powerful when you think about data extraction. I mentioned at the start of this, I'm co-chair in the PDF UA technical working group and the chair of the PDF reuse technical working group. And these two things go hand in hand. Good semantics powers accessibility. Good semantics powers reuse, content extraction, data extraction. So by being able to understand PDF, you can slowly start to unlock the power that was inside that PDF. You can even start to take structured data and take that out of the system and put it into other places, CMSs, and republish and reauthor. I would argue that these projects, not any one, not Adobe specifically, but across the industry, Foxit has a great implementation. We've seen the adaptation of this technology, and I think it did solve some of the key problems for readability in PDF on small devices. It slowly opened up accessibility. No one would say it's perfect, and I think some of the comments earlier about automated tagging and the challenges there are very real. We're not saying it's a perfect solution by any stretch of the imagination, but you can take those trillions of PDFs, and if you just receive one on your device, you can hit a button on many vendors' software and now see an adaptive and responsive layout. You can take that content and put it elsewhere and reuse it. But this was a very... Did my audio just cut off?
Yeah, it went.
I think this might have lost power. Oh, sorry. Okay, testing. Is this on? Yeah. Okay. So, sorry. So this was very successful, but it was also very, very costly and data intensive. To train AI models to be accurate enough to recognize these complex objects, this variety of content that we see in documents, and even to hit the 80 or 90% use case, it cost millions and millions of dollars. It's not cheap. And it's very brittle, meaning if I decide that now I want to do something new in that data, I have to build a lot of data to get to that new requirement. And so it was successful. We benefited a lot as an industry through these experiments across various companies, but it's not a long-term solution. So, again, I'm not going to say anywhere in this talk that we've solved every problem, but these are some of the things we have looked at when we go beyond classic ML to generative AI, large language models, transformer models, effectively. Sorry, everyone. Testing? Thank you. Okay. Thanks, Melina. So, I jumped ahead there unintentionally with this. So, yes, so we started. So let's look at some of those limits of the classic models that we have. As I already mentioned, they're brittle. Domain adaptation is very hard with them. Every time you take on a new problem, you have to go back, build a ground truth, source lots of data to solve that problem. It's incredibly costly. The performance, when I say performance, I'm not talking latency, but ML performance in terms of, quality, the retrieval capabilities, goes down the more complex the model you get. So if you try to recognize more and more features of a document, the harder it becomes for classic AI to do that. You need bigger models with more data to differentiate and to do that. If you want to move those models onto a smartphone, for example, you're fighting against the natural limitations of those systems. Though you can do it, we've done it. Sometimes, especially, you can do unstructured data handling, but it can be very hard to do with these models. You can't just train on unstructured data, for example, to learn new. With classic ML, you have to really have training examples that are meaningful, that are labeled, that allow you to actually build ML. Which means that you have to manually engineer every feature you want to detect in a document. And so that's a pretty complex and costly process. The data sets are usually narrower than you would like. You find a new case that you just haven't covered, and it becomes costly to draw that in. And you end up with a lot of handcrafted rules that I think limit these techniques. So, I think everyone knows in November 2022, it wasn't the first instance of a large language model, but with ChatGPT, large language models finally became, I think, somewhat useful and transformational. And basically, they're just trained on, I think everyone knows a bit about them. I'm not going to, in this talk, go deep into what a large language model is or does. But they train on just vast quantities of information. Instead of millions of parameters, they have trillions of parameters that they can train on to become capable of doing what they do. They basically they're still neural networks, right? They still work like a classic ML model, but just on a scale that's vastly different. And the transformer technology, the ability to take a large set of content and predict one token that comes straight after that is the most likely next token for your content, is crazy that it then produces this vast, rich content just by producing one token at a time, very fast to produce content and to produce output. And so that's basically the underlying difference between large language models and what came before. Why they matter is that they can be vastly more dynamic and capable than classic ML models. At Adobe, we spent years trying to train AI to do things like good summarization. You could do it for one vertical market. Maybe I could get financial documents. Maybe I could get healthcare. But to try to get a broad summarization model just wasn't happening until large language models. And the impact is huge on these things. They're not perfect. I think we all know that. They've got a long way to go. But it's transformed the way AI can interact with content. So when you look at it, when you think of PDF as an ecosystem, these classic ML models are specialists. They tend to do one thing or one category of thing really well. But they don't expand, they don't broaden. And they're still very valuable. We still build classic AI all the time to solve classification use cases, very specific things. Maybe you want to distill a big use case down to a smaller one to run on device. They're still very valuable. No one's throwing out classic AI. But these transformer generative AI models, these large language models, change the game a lot. And when you think of PDF as an ecosystem, it's very broad. When you look at the products like Fox Viewer and Adobe Acrobat, the things that open PDFs, every day for users, and all the systems that the OS versions of these PDF viewers, it's so broad that you need something that scales with that breadth of documents. You need something that allows you to actually, sort of go to those broad use cases to really be successful. Classic ML just doesn't scale to that. But with large language models, we're starting to see that scaling be possible. And so let's talk a little bit now. Let's get into the meat of the talk, so to speak, about how we're actually looking at empowering the future of PDF with AI. So a little bit about large language models and why documents are still very relevant to them. So large language models are trained on vast, vast, vast quantities of data, basically the entire internet, right? But they're still limited. If you look at the latest releases of OpenAI's models, maybe they're trained through late 2024. Maybe the very, very recent ones get into early 2025. But training them takes a long time. So they naturally cap out at a certain date where they were last trained. And so that's the intrinsic knowledge that's built into an LLM. And this is why they hallucinate, because they have all this knowledge. But it's also why they're so valuable, is they've pulled in this vast amount of data. People enhance large language models using techniques like RAG, so retrieval augmented generation. There I can connect a data source. Maybe it's a database behind the scenes, maybe a help repository. And I can connect those two things, and that allows me to bring in relevant new information. And so RAG is a very common way if you're providing a help system for your help documentation or content beyond what the LLM knows intrinsically. That's how you tailor it to a specific use case. But it's still broad, right? It's still likely to be at a company level or a product level. The thing that I think we should focus on is how documents play such an important role in this. Documents are personal. They are relevant to you and your use case. Documents contextualize the things you want to do. And so that's why it's so valuable that we're building these AI systems that take documents as input and then allow us to use this LLM capability on those documents to answer questions, to do all these things. And so by combining these systems, so the vast and intrinsic knowledge within the LLMs, RAG techniques to pull in external knowledge sources that are relevant to your use cases, but then your personal document or documents. That's what's so transformative about AI today with the products we're seeing where they use it. PDF goes from being a static single artifact to something conversational. You can talk to it. You can ask questions of documents. You can interpret those. You can have it reinterpret and reimagine. You can translate on-the-fly content, simplify the language. There's so many potential opportunities. You can tailor summaries to specific use cases and audiences. You can combine the contents and knowledge of PDF. I go into these in a bit more depth on subsequent slides, so I'm just keeping this high level. But more importantly, you have those documents. When you answer a question from an LLM, it really doesn't know where it got the answer from. It's just intrinsically in that vast store of knowledge. But when you're answering questions that are grounded to the documents you have, you can actually cite where that comes. You have some identity for it, the provenance for where that content comes. And so binding it to a real document or set of documents becomes much more powerful and much more trustworthy than a lot of just standard answers from a chat model. So let's think of some of the things you can do with a conversational workflow with PDFs. There's many, many things you can do. But start with self-explanatory documents. So here, it's not that the document itself is explaining itself, but connected to the power of an LLM, you can have it answer complex questions. And it's not just one document. I could take financial earnings over several quarters and then ask it to synthesize an answer that tells me about that, the trends, the information that's present across documents. So all of a sudden I can get new insights that are only available once you combine these multiple knowledge sources to provide great answers. Those answers can also be personalized. It's very common. I think anyone here who uses GPT or something like that, they let you describe yourself. What's my role? I can say, hey, as a director of engineering at Adobe, I would like to know about this topic on engineering, and it will probably assume that I know a little bit about software and how code is written, and it won't have to simplify that too much for me. But if I come along and say, I'm a medical doctor and I want to know about this topic, it may not assume the same knowledge of coding that I would have, but it would also not assume that I have the medical knowledge that a doctor would have. And so these AIs can actually take that core content and adapt it to you as an individual or you as an organization. And so this is, again, something where any one document can't be for everyone. But hypothetically, in these cases, we can start to actually have documents that can be repurposed and reused for everyone. We have simple navigation in PDFs, but it's impossible with bookmarks to think of every use case. It's impossible to think of all the things you might wish to do with a single PDF. And so basically, this is something where navigating based on topics and themes, again, through attribution back to where content came from, allows me to move between a body of content, documents, and the answers that I get from AI. And when you think about collaboration, yes, you can today do collaborative things like commenting workflows and review and approval and those sorts of things, but people can actually come together with chat and actually understand documents much more richly through shared interfaces where they're all talking to the same document and with each other. So there's a lot of potential just from conversation with PDF through these large language models. One use case that really speaks out to me as someone who's been so involved with accessibility for so many years is, I think everyone knows that alt text sucks. Basically, we always ask people to put alt text into documents to describe an image. How on earth can you choose one string in a document to adequately describe an image in all contexts? As we all know, images have a lot of contextual information from the document around them. The same photograph, the same data placed into a PDF may not mean the same thing without that additional context. And so the beauty of large language models is that newer models can understand the images themselves. They can look at those images, but they can also look at the context around those images. So if you think about the traditional solution where you provide this one string that tries to walk a fine line between too much information, too much detail, and not telling the user what they need to know, with large language models you can go much, much further. So first, you've got the understanding of the AI to actually know what the image is about, and you can read the document to understand the context. You can then start to conversationally interact. You can ask questions of the image. Tell me about it. Tell me who the people are in it. Are there people in this image, right? You can start to interrogate an image in a way that you just can't do with one alt string. That's going to be impossible. And so no one's saying don't put that alt text in, by the way. We still need that as a basis. But beyond this, LLMs unlock so much more potential when it comes to accessibility. And not just accessibility, but understanding. Recently, I received a financial report for I'm on the board of directors for a small nonprofit in the Bay Area. And they sent out their financial data for the last few years. I dropped it into ChatGPT and had it explain that data to me, and it was really, really powerful and helpful in explaining and understanding this complex data that I'm probably not financially knowledgeable enough to understand without that. And so it allows me to transform this content into more accessible, more reusable, more understandable types of content. I can tell you, hey, read this data and tell me what the earnings were for the last quarter. I don't have to try to read through a lot of data and figure out that answer. I've touched on this quite a bit already, but I want to go into this a little bit more detail. So I can synthesize new information, or at least stuff that if I just read the documents, I'd have to understand them very deeply to build the connectivity to really understand the connections across documents. So with a single document, most people can probably read that document and keep enough of an understanding of what it's saying. But imagine I have 20, 30, 40, 50, 100 reports on financial earnings. It's going to be really hard for me as a user to pull out any detailed analysis on that. And so this is where, synthesis, the ability to generate something new from something else, is really critical to how we can use these documents. It makes these larger stores of documents that we all have much more useful in the future than they are today. I can summarize across domains and multiple sources. I can, potentially extract insights into new material. I can build new documents. I can get the citations to understand where the content's coming from. And finally, it helps me personally accelerate my own research. When I'm trying to learn a new topic, I can certainly use this to facilitate. It doesn't mean that the original documents don't still have a lot of intrinsic value. I'm still going to read those documents a lot of the time. But I may not need to read every single document that I have. I may not need to go into depth. I actually had a great example of this recently where Duff and I were talking about, we'd just done a reuse meeting where I explained the history of an ISO standard 32005 and why we got to the state it's in, what the history of that was. And Duff and I said to each other, this would be really useful if we wrote up a tech note on, I know you probably don't like this example, but if we wrote up a tech note that described this history. So I thought, well, that sounds like a lot of work. And Duff very kindly offered to take a first stab at it. But I said, I'm going to try to use AI for this. I took the transcript from the video that we'd recorded. I took an existing tech note as an example of what a good tech note looks like. And I asked AI to generate a new tech note based on my content and my history. And I gave it just enough information about the context, why I wanted to do it, that it produced a pretty passable first stab. You said it was pretty passable. You can't deny. Yeah. It wasn't perfect, right? It's a starting point. AI is not going to get you 100% of the way, but it's going to get you a big chunk of the way there. And so it's very valuable. So the ability to synthesize new information from documents and to use these in creation of new things is still very valuable. In fact, it's also very valuable when you take the data that's locked in PDF and turning that into new insights. And so you can do things like, ask questions, make decisions based on the content in documents. Again, proviso, it's never going to be perfect. You still need to understand your content. But you can use AI to understand when things are happening, to read documents and let you know what the trends are, what the characteristics are, to drive decisions. You can basically readapt content to new visuals. I can take a table that's really complicated. I can ask it to generate a chart that helps me visualize that differently. I can ask that chart to focus on specific aspects of the data, not just all the data. So I can adapt that content to my need and not be limited by the one image that was in that document or that one table of content. I think everyone knows tables are the worst way to represent data, except the only good way to do it on paper. And so basically, by combining those rich data sources of tables, but with visualization of those into new forms as you need them, that's the power that LLMs bring. And coming back to that, I think this is really important. LLMs hallucinate. They make stuff up. So it's not just about people being able to check, but software needs some way to check. By grounding on the document's content, you can verify that the information you're presenting is actually real, is correct. And so a lot of the work that we do is going into the document sources, maybe using multiple large language models to verify each other, to make sure that the data we're presenting you is correct, or that we can look up that information and verify it for you. And ultimately, static content locked in this final form, A4, US letter, fixed page, now becomes dynamic, rich. Yes, we could power things like reflow and derivation, but even more, I can adapt generative interfaces that allow me to interact with that content much more richly. You can ask for the best representation for that content, and it can automatically generate that based on your personalized information, what it knows about you and what you like to consume. Some people prefer to listen to their data, right? Some people prefer to see it. Some people work best when they can do both. This unlocks those capabilities of being adaptive. So, to wrap it all up very quickly, and I think I'm coming to about the right time, there's a lot that we will do. LLMs are not perfect. They're evolving all the time. No one's suggesting that the solution is perfect today. But a lot of this is already present in products. No one product does everything I've just listed. But if you look across all these different vendors, you can do everything I talked about today with varying levels of quality. So documents become knowledge ecosystems. There's a value to having documents, and those documents ground and contextualize the things you want to know about. AI can then transform the PDF into something that works for you, that turns it into something that meets your needs. It can even go beyond that and create. In fact, I meant to mention this when I got to this set of slides. You'll notice the visuals changed a little bit between the first half of the deck and the second half. And that was very intentional. I actually wanted to try to bring more AI into the second half of the deck. So I used tools like Napkin AI and other artificial intelligence to try to present my information more richly. Not everything's perfect. I'm sure there's some places that I would have done something different. And it wasn't just a one-shot. I didn't just say, produce this. I interacted with it. I tailored it. I transformed it and went through various rounds of iteration to get it to what I wanted. But anyone who saw earlier versions of this deck would have seen a very text-heavy deck rather than one that slowly transformed into a more visual deck. And so that's what I talk about with AI-powered creativity. You can reuse the content in material and then work with AI to produce something more powerful, more rich. And I do think this plays a big role in accessibility. The ability to understand documents, to transform it, to simplify or make the language more complex, to translate it on the fly. There's so much potential for the future of accessibility that I do think that this is a massive unlock. It doesn't mean that we shouldn't be producing tagged PDF. A good source tagged PDF is always the best input into one of these systems of any PDF. But I do think that just as the human brain spends a lot of time understanding the layout and the structure of documents without any markers, any logical structure there, AIs can do a lot of this now. And with a little bit of more training, they can do a significant chunk of what we need to produce great accessible content from potentially any document. So when I think about the next chapter of PDF remains a document of record. It's very valuable as that context and content that you need. It's something you can refer back to, read, print. It has all the value that it originally had. With AI, you can transform that into the purpose you need for it. It can just be a summary helping you decide if a document's relevant to your thing you're trying to research. It could be transforming that content to help you better understand it. But AI can then play a big role in this. So the next trillion PDFs that are produced should be ones that power this. They should be accessible. They should be data-rich. They should be the sorts of things that will actually help us make better use of AI rather than limited to these really flat, two-dimensional pages. And I do think that we as a community in the PDF space have a large role in defining what AI should and shouldn't do with documents. I don't think there's any perfect answer for where the limits should be. But I would like to engage this community in the future and beyond to really define what is the value and how do we drive that value of AI in documents. And so I'll leave you with this. The next trillion PDFs won't just preserve knowledge, they'll empower it. So thank you.